Hello, good morning student. How are you? I hope you all are happy and healthy and fine at home. So, what did we discuss yesterday? We discussed about the strength of organic acids, and on the basis of their pK value we have seen the different application of organic acids by considering all above points like inductive effect, then resonance effect, and now means today we are going to learn the second point, that is strength of organic bases, that is a basicity. Why some of the bases are stronger, why some of the bases are weaker, what are the factors that affecting the strength of basicity, that we are going to learn similar to the strength of acidity, right? Now here just you remember, basis means what? According to as a Lewis basis, a substance which can donate the pair of electron to H plus is known as basis. Means these are the atoms that contain lone pair of electron to donate. So that type of the thing is known as a basis. For example, it may be, suppose we have a base which is lone pair and it will pick off the proton and you are going to get here BH positive. That type of the species you are going to get here. Or sometime that basis may be negatively charged species. Suppose let us see here B negative charge, then that will pick up the proton and you are going to get here BH, that is a neutral species, right? Positive, negative and resulting compound. Let us see, for example, here we have a OH minus and then H plus combined together produce H2O, water, which is a neutral in nature. So that is this thing is called as a basis. And the basis, what are the, it depend upon what type of the it depend upon the following factors. Number one are the, what we can call it as the factor affecting the strength of basicity. Number one, what is that? Number one, let us see here one by one very clearly. Number one, which is known as the availability of lone pair. First one, the availability of lone pair. Availability of lone pair, that is the first thing. If the number of lone pair, just now we have seen one example, there is a lone pair present on it, it can donate the lone pair. Means first factor, the availability of the lone pair is in a great, then it has it will be the more basic in nature. Now let us look at as a second point which will affect the strength of basis. Number one, the tendency to donate lone pair. So this is the second criteria. Means those are having as a lone pair, they have a great tendency to donate the lone pair, and therefore that is the second factor which can affect the strength of basicity. And now third one and the important one, the stability of conjugate acid, the stability of conjugate acid formed after donation. So these are the three factors which can determine the strength of basicity. Number one, the availability of the lone pair. Number two, the tendency to donate the lone pair. And number three, the stability of conjugate acid formed after donation. So that are the three main factors which deciding the strength of basicity. In addition to this, as we know that the plus I inductive effect as well as plus R inductive effect, they increase the basicity. That is one of the point you should remember. If the plus I inductive effect and the plus R inductive effect is present in that compound, the basicity goes on increasing. Similarly, suppose you have a minus I inductive effect and the minus R inductive effect present in the organic compound, they will decrease the basicity. Of that basis or that substances. So these are the factors you should keep in mind while deciding. In addition to that, there are some other factors also. Solvation. So that is a solvation. It is another factor which can be involved for determining the strength of bases. So that are some of the factors. By keeping in mind, we are going to see some of the application of this type of the compound. Now let us see the first application. Methylamine is stronger base than ammonia. Let us see the first application. What is that application? Let us see here, because by considering here again one more thing remember here, what is that? The basicity again depend upon their pKa value. pKa value means what? In acid we have seen, if the pK value decreases, the acid strength goes on increasing, but here you do the opposite one. Opposite one means what? If the pK value increases, the basicity goes on increasing. Remember, pK value increases, basicity increases. pK value increases, basicity increases. So that is one of the thing you should remember while considering this type of the applications. Now let's move on to the first application. What is that first application? This one, methylamine. Methylamine is stronger base than ammonia. Explain. Okay. Methylamine is a stronger base than ammonia. Everybody or most of you knowing the structure of ammonia as well as structure of the methylamine. You might be knowing as a amine is one of the chapter at your previous classes in 11th standard or 12th standard. Amine means what? The organic compound having a general formula RNH2 is known as a amine, where R is a alkyl group or aryl group and NH2 amine group is a functional group. And as we know that functional group means what? It is a site of the reaction. Whenever we are adding as a reagent, the changes are occur at a particular part of the organic compound is known as a functional group, or in another way, the atom or group of atom that determine the physical as well as chemical property of a particular family of the organic compound is called as a functional group. So let us see, and that amine further get divided into as a 3 types. One is a primary amine, secondary amine, and the tertiary amine. We are not going to go into that one, but here just the sake of convenience, how many you are able to draw the structure of methylamine? First tell me the structure of ammonia. Everybody knows the structure of ammonia. Very good. So this one NH3, that is the structure of ammonia. Nitrogen containing 3 hydrogen atom is known as ammonia, and ammonia is a basic. And again one general statement or one guideline you remember, those organic compound containing nitrogen atom are basic in nature. Why they are basic in nature? Because nitrogen atom containing lone pair of electron, and according to the Lewis theory or Lewis basis is a substance which can donate the lone pair of electron, and therefore nitrogen has a tendency to donate the lone pair, and therefore it acts as a basis, and therefore ammonia is a basic in nature. And here this is a ammonia, and it has a pK value, I think 9.8 something. pK value of that ammonia is a 9.8 roughly, because we are going to consider this strength of bases and their pK values on the basis of their pK value. And now when it is attack on that proton, what do you get? You are going to get here NH2 4 plus ammonium ion. This one is a ammonium ion, right? Ammonium ion. IUM, that clearly indicate as a positive charge on that particular atom, and that's why it is called as a ammonium ion. And this ammonium ion, this is a short form there, NH4 plus, that type of the ammonium. And there is a no question about plus I inductive effect as well as minus I inductive effect, and it is already stable compound form there, NH4 plus. Now let see the methylamine. Everybody knows that the methane molecule CH4, one of the hydrogen atom get replaced by NH2 group. The resulting compound is known as methylamine. Let us see here, as we know, this is the CH3, this is a methyl group, and then connect the NH2 group, that is a methylamine. The name of this compound is a methylamine. This is methylamine, and the pK values are given. pK value is, I think, 10.6 is given here. So methylamine has a pK value is 10.6. Now when attack the proton H plus, what do you get? This lone pair attacking on that proton, the resulting compound obtained will be CH3, then NH3, positive charge over there. Now look at the methyl group. Here methyl group, what type of the group it is? Whether it is a electron donating group or electron withdrawing group? Yes, it is a electron donating group. And if electron donating group is present, what type of the inductive effect they show? They shows the plus I inductive effect, and therefore there is a plus I inductive effect. And what I said at the beginning, plus I inductive effect, it increases the basicity, because when this lone pair already present on the nitrogen atom, again this methyl group, they are the electron rich spacing, methyl group again giving the electron to that nitrogen atom, and therefore it becomes as a more reactive. And this conjugate, this one is called as a conjugate acid. Here again this is a conjugate acid, and this conjugate acid is well stabilized due to the plus I effect. This is a well stabilized due to plus I effect. That is the answer over here, or this is the justification of this methylamine is a stronger base than the ammonia. Understood this one, how it is, and here methylamine is a stronger. If you compare the pK value, what I said, if the pK value increases, basicity goes on increasing and the acidity goes on decreasing, remember here, and therefore these are the basic methylamine, and all methylamines are stronger than the ammonia, because all methylamine, all the alkylamines are stronger than the ammonia. All alkene means which alkene? Primary, secondary and the tertiary. Let us say here, suppose second application of this, what is that? Let us see here. Second application. Let us see the second application. Secondary amine is stronger than, or secondary amine is the strongest than the dimethylamine is stronger than the primary amine. You can remember second. Dimethylamine is a stronger base than methylamine. Explain or justify your answer. Now dimethylamine is a stronger base than the methylamine. How will you explain? What is the first things to do, or what is our first job to do? First, while answering such type of the question, you must remember, you must know the structure of the organic compound. Here dimethylamine and here is a methylamine. Two structures, if you draw correctly, you will get as a half mark or 1 mark, and the rest of the thing for the explanation. And now here dimethylamine, we know that the structure of dimethylamine is this one, CH3, then NH and this CH3. This is the structure of dimethylamine, and this I think having pK value is equal to 10.8 something is there, 10.8 pK value. And we know that the structure of methylamine, we have seen just now, right? And what is their structure? This is CH3, then NH2, lone pair present on it, and therefore this is the structure of methylamine. This is a structure of methylamine, and which has pK value, just now we have seen 10.6 something is there. Roughly I am writing as a pK value, but only remember, if the pK value increases, basicity goes on increasing. That is a common thing you must remember here. Now as we know that here is a H plus, when attacking that lone pair on that, you are going to get here this one CH3, NH, or here H, positive charge over there, then you are going to get here CH3. Similarly here also H plus, again this lone pair attacks the proton, and the resulting compound you are going to get CH3, then NH3, positive charge. Whatever this resulting compound are known as conjugate acid. These are the conjugate acid, right? Conjugate acid. These are the conjugate acid. And third factor we know that, what is that? The stability of the conjugate acid formed after donation, and after the donation whatever conjugate base is formed, because lone pair donating over there and we are getting as a conjugate base form, and that conjugate base is well stabilized due to the plus I inductive effect. If you see this structure carefully, what do you see over here? Here are two methyl groups. both are electron donating group. What type of the effect they shows? They shows the plus I inductive effect, right? Plus I inductive effect. If you compare the magnitude of plus I inductive effect, there are two plus I inductive effect, means magnitude of this plus I inductive effect is greater than this. Here is only one, here are the double, and therefore dimethylamine is a stronger base than the methylamine. I think with this, let us stop today here. Remaining application third onward we will see tomorrow. Thank you. Have a nice day.